We are given the derivative of a function w of t. The derivative dw over dt represents the rate at which the landfill is increasing. The equation is 1 over 25 times w minus 300. So at time t equals 0, the amount of solid waste in the landfill is 1,400 tons. We plug in 0 for t in the derivative function, which can be substituted with 1,400. We get 44 as the slope of the tangent line at t equals 0. Using point-slope form, we find the tangent line to be y equals 1,400 plus 44t. To find the approximate amount of solid waste at the end of the first 3 months of 2010, we plug 1/4 into the tangent line for t. We get approximately 1,411 tons of solid waste in the landfill.
We are asked to find the second derivative in terms of w. In order to derive the given function, we must use chain rule. So when we derive, we get 1 over 25 times w minus 300 times 1 over 25, which simplifies to 1 over 625 times w minus 300. Using this equation, we plug in the estimate from part A, which was 1,411, in for w. By doing so, we get 1.778, which is positive. Therefore, the second derivative is greater than 0, and the answer in part A is an underestimate because the function is concave up.
To find the particular solution w equals w of t to the first derivative with initial condition w of 0 equals 1,400, we must use separation of variables by dividing both sides of the equation by w minus 300 and multiplying each side by dt. Then we integrate both sides, which becomes ln of w minus 300 equals 1 over 25t plus c. By substituting in the initial condition for w and t, we end up with c equal to ln of 1100. So once we solve for c, we go back up to the equation ln of w minus 300 equals 1 over 25t plus c, and plug in ln of 1100 in for c. Then we e both sides and simplify the equation to get w of t equals 300 plus 1100e to the 1 over 25t.